Thank you, everyone. My name is Amir Shabar. Welcome to another webinar, Toronto Centre sponsored webinar of CMOS. Today's author is Mike Flannigan, Dr. Mike Flannigan. Mike is a research chair for predictive services, emergency management and fire sciences at Thompson Rivers University, and the scientific director of the Canadian Partnership for Wildland Fire Science. He received his MSc in Atmospheric Sciences from Colorado State University and his PhD in Plant Sciences from Cambridge University. Dr. Flannigan has been studying fire and weather-climate interaction, including the potential impact of climate change and lightning-ignited forest fire over 40 years. Today's topic is wildfires and climate change. What does the future hold? Over to you, Mike.
Thanks, Amir. I'm joining you from Kamloops, British Columbia, and this is the traditional and unceded territory of the Kamloops people. The meaning of Kamloops means where the rivers meet. And if you've been to Kamloops, that's exactly where the rivers meet. I'd like to mention that, for the old timers out there, I was on MT course 35 back in the 70s. That was the last MT course. This is a meteorologist in training course that I took, and I worked as a meteorologist for Atmospheric Environment Service for a few years before joining the Canadian Forest Service. So some of you may remember we had instructors like Dave Phillips talk to us about climatology, and Bill Burrows taught us dynamics. So the original talk was focused entirely on climate change and wildfire. But with the uncharted territory we're entering with the 2023 fire season, I've squeezed in a chunk of what's going on, or at least what's going on thus far in the 2023 fire season. So, the first couple of pictures you've seen, pyroconvection. I'll talk very briefly about pyro-CBs, pyrocumulonimbus, fire-generated thunderstorms, because it's a record-breaking year for that as well. So we're going to talk about fire in Canada, so everyone has a background, because, so we all have the same starting point. Then I'm going to talk about the 2023 fire season in Canada. It's just crazy. And then fairly briefly, impacts of climate change on wildfire. And I'm not going to talk about, what can we do about it? There are things we can do, but save that for another talk. This slide here is 2017, July 14th. That Ashcroft, BC's in your foreground there, and that's the Elephant Hill wildfire in the background. And it was about 35 degrees Celsius, and RH was 12 or 13%, and the winds were gusting in the 40 kilometers. Hot, dry, and windy. And 2017 really heralded the new fire seasons in British Columbia, because 2017 became the record-breaking season, broken by 2018, and 2023 is going to break it any day now. So stay tuned. So when we talk about fire, there's the direct impacts of the fire. You can lose structures or communities, but there's also the indirect impacts, smoke. And this bottom picture, if you can see my cursor, live right about here. And you can see the people are in the valleys, and so is the smoke. And this year is a particularly bad smoke year. I'll talk briefly about smoke. But then there's what I call cascading impacts. And so this is the Coquihalla Highway. It's a major thoroughfare from the interior to the coast. And there was numerous fires in 2021 along the Coquihalla. In November 2021, we had a significant atmospheric river event. And many of those areas where there were fires, there was also flooding, debris flows, mud flows. Like the fires didn't cause that, but that increased the probability of flooding and mud flows, because the fire killed the trees. So there's no canopy to intercept the precipitation. There's no live root system to suck up the moisture. And some ash is what we call hydrophobic. it repels water. So it's almost like concrete. So flooding is much more likely. This is from Bowman et al. In 2020. It was a review on fire and their system. And it just, I like this slide because it kind of shows all the interaction between fire and our climate system, our cryosphere, our hydrosphere. So fire plays a role in many aspects of our climate system. So just some basic facts of what's going on in Canada. We get about 6,000 fires a year. About half of them are started by people and half by lightning. People cause fires dominate in the spring. After the snow goes until things green up, there's a window where it's easy for fires to start. And there's a recent paper by Mark Prigent on that very topic in global change biology that's coming out. And, if you're interested in it, give it a read. We burn about, on 10-year average, about 2.7, 2.8 million hectares. That's doubled since the 70s. And many papers attribute, and I do as well, to human-caused climate change. Largely, not solely. These fires in boreal are often high intensity, what we call crown fires. I'll talk about that briefly. There's a great deal of year-to-year variation, and we're seeing the upper end of that variation right now as we approach 10 million, and we still have a good chunk of the fire season to go. And I attribute that largely to variation in the fire weather that year. I mentioned that lightning causes about 50% of the fires, but it's responsible for 80 to 90% of the area burned. There's a number of reasons for that. We can talk about it if we have time. Fire, it's all about the extremes. 3% of the fires are bigger than 200 hectares. A hectare is about the size of a soccer pitch, but they represent 97% of the area burned. And much of this happens on a relatively small number of extreme fire weather days, those hot, dry, windy days. We call them spread days, days where there's active fire spread. Now, on the chart on the left bottom is area burned in BC since 1950, where modern records began. And you can see number 1 is 2018. Number 2 is still 2017 until today or tomorrow. We'll probably pass 2017 if we haven't already. And 2023 will. And number 4 spot is 2021. So the 4 biggest years have been since 2017. And yeah, it's seems we get a bad fire year every couple of years in BC now. So, and fire isn't the BC problem. It spreads from coast to coast to coast, or sea to sea to sea. And there's lots of fire. You can almost see where the boreal forest lies. That's where the fires are. And where there's fire and there's communities, there's evacuations. And once again, sea to sea to sea. And this year, there's been numerous evacuations pretty well across Canada. And I think the number is over 100,000 people have been evacuated this year thus far. There's more evacuations in BC at this time, so that number is going to increase. So this is a work done by Lynn Johnston, who's with the Canadian Forest Service, and she was looking at the traditional wild and urban interface, the industrial interface, and infrastructure interface. And you can see the southern tier of our forested, especially the boreal forest, there's development. And, so there's fire, there's going to be an intersection and impacts from that. And we often talk about number of fires, area burned, because those numbers are at our fingertips. Impact is much more difficult. There's economic impacts from evacuations, there's the cost of fighting fires, but there's also the social impact. Evacuations are very stressful. Losing your home is extremely stressful. So there's a lot of impact to fire that's much more difficult to measure. So it's just some basic facts here that people should be aware of. We often talk about 3 types of fire: ground fire, surface fire, and crown fires. So ground fire means it's burning in the organic layer, and it's often in peat and bogs. Sphagnum mosses can sustain smoldering combustion for years in places like the tropics, it can be decades. Surface fire just means on the forest floor or the earth's surface. And then crown fire, it spreads from the surface to the tops of the trees, the crown of the forest, crown fire. Conifers in this country are much more flammable than broadleaf trees. Closed canopy coniferous forests are prone to these high intensity crown fires. They're almost impossible to extinguish through direct attack. You have to use indirect attack through burnout operations. And fire typically enters a community through a rain of burning embers, not through the flaming front, the fire front. So this rain of burning embers, and this becomes important because the wind could carry these burning embers a number of kilometers. Documents of 2, anecdotally I hear up to 5, in Australia even longer distances. And that's a challenge to protect communities when you've got this rain of burning embers coming down. And you see in the bottom, there's pictures of the 3 types of fire. Top left there, that's end of June 2021. That's a Sparks Lake Pyro CB that's was just massive, had 7,000 lightning strikes, started 40 new fires, quite an event. So just some basic ecology facts. Fire is a natural component of our boreal forests, and these forests survive and even thrive in a regime of semi-regular stand replacing, stand removing fire. Fire removes the competition, allows sunlight to reach the forest floor, and reduces the organic layer, so you get mineral soil, which prepares the seed bag. How did trees survive this? So, well, they don't necessarily survive, but their progeny do. So pine and some spruce have serotinous cones or semi-serotinous cones. It's sealed with waxy resin, and the heat from the fire opens the cone and produces seed. So you have a stand of jack pine, a fire goes through, kills all the jack pine, but all the cones release new seeds and you get a new jack pine stand. Aspen suckers, some of the trees like red and white pine have thick barks that survive surface fires, but not the crown fires. So fire management. Canadian fire management agencies are among the best in the world. It's a hot job, it's a hard job, it's a smoky job. And, a lot of people don't realize that it's the crews on the ground that put the fires out. Aerial attack helps. Aerial attack buys you time, but it's the crews on the ground that do the putting out of the fires. We use something called the Canadian Forest Fire Danger Rating System. It's used across Canada and actually many places around the world, parts of it. It is getting old, and things have changed in the last 40 to 50 years since it was developed. And so the Canadian Forest Service, led by Mike Watton, is working on the next generation of the fire danger rating system. Fire management is challenging, and it's becoming more challenging because there's more demands on the system, on fire management agencies, and the climate is changing. That hot, dry, windy component is becoming more severe. So we spend about $1 billion. This year, we're going to spend more than $1 billion on fighting fires. And that number is going up. It's going up faster than the area burn numbers. Of course, health and safety Canadians, a priority, smoke. We're seeing more wildfire disasters. This is from the Canadian Disaster Database. It is in the process of being updated, and hopefully we'll update this chart soon. But most of these are due to evacuations. But you can see the disasters, according to that definition, is increasing. So is status quo viable? I don't think it's sustainable. I think we're going to have to change the way we fight fires. And I think the process has started, and I don't have all the answers. I can highlight some of the problems and some of the potential solutions, but we need to work on this. We need to get a lot of people together from all sectors of fire management to solve this, or at least to find out what the best practices are under the current situation. Fire, I often say it's like real estate, location, location, location. This is the Slave Lake fire of 2011, and you can see the fires coming into town right along the highway there, and it did come into town. And at this time, there were spot fires occurring in Slave Lake 2 kilometers, even though the fire was still 2 kilometers away. So, you know, if you've listened to the news, you know, over the years, there's been lots of fires in various parts of the world. 2016, Fort McMurray, of course, numerous fire events, unfortunately, California, Australia, and this year, Chile had a very active fire season, and now Canada. So smoke, there's a new paper out. I just saw the notice for it this morning about smoke-related fatalities, wildland fire smoke, and I think that number is going to go up. But the last paper I read, which about 10 years ago, was around 330 or 340,000 premature deaths. So smoke has significant impacts. Most of those fatalities are in Southeast Asia, where they have peat fires. Every year they have a season of peat fires and the smoke associated with it. And speaking of smoke, this isn't from this year. I have lots of examples from this year, but I like this example because for the atmospheric scientists in the group, you can see the low pressure system, the smoke's being entrained in this low pressure system. There's also a subtropical low that smoke's getting entrained to, and smoke's getting entrained into a low pressure system in Eastern North America. Smoke can travel thousands of kilometers. It can be injected into the stratosphere, and the stratosphere is a very stable layer, and it can stay there for weeks and months and even longer, encircle the globe. And yeah, smoke is a byproduct of fire, and you know, it made major news this year because it hit northeastern United States, affected millions of people, postponed baseball games, shut down flights. Yeah, they got a real taste of smoke, and spread to Europe already. So my simple view of fire is there's a recipe. You need 3 ingredients. Vegetation, fire people call it fuel, of course. What type, how much, how dry, important aspects. Ignition, people, and lightning. And weather, hot, dry, windy weather, extreme weather. You get all 3, you have your fire. So now I thought I'd transition into just an overview of 2023 fire season thus far. I try and put links for stuff that I use. This is from CIFC, the Canadian Interagency Forest Fire Centre. This is a screenshot from yesterday. You can take a look. I would suggest, if you want the detail, to click on the National Situation Report, and it gives you a lot of detail. Some of these fires are just being monitored. Not all these fires are being fought, but you'll notice that there's over 500 fires that are out of control. I've never seen that number before. BC alone has over 200 fires that are out of control as I speak. 9.7 million, that's larger than the country of Portugal. It's New Brunswick and lots of PEIs thrown in for American folks. It's larger than South Carolina, just a bit smaller than the state of Maine. And, you know, 880 active fires. And you can see from sea to sea to sea, there's fires around the Arctic Circle. Hey, Norman Wells reached 100 degrees Fahrenheit the other day, which is mind-boggling. Norman Wells is in Mackenzie Valley, well north, 65 degrees north, 64, I'd have to look it up, but well in the 60s. Yeah. So, and here's a graph that really stands out. It's 2023 is like a sore thumb, okay? Now, this doesn't have all the years on our modern record, which goes back to 1959. The previous record for area burned in Canada, and there's multiple data sets, but it's around 7.5 million hectares, 1989. And here we are, and we're kind of in the midway of the fire season, and we're 9.7. So we broke the record, we smashed the record, we're in uncharted territory. Why? What's going on this year? And, you know, you have to put in a larger context. You know, you look at the heat event the southern states are going through right now, the water temperatures in Florida, the flooding in New England, the flooding in India, you know, like there's just all sorts of extremes, and that's consistent with a stagnant jet stream. And we'll talk about that a bit later. So there's a link for this site. They do update every day or two, and that was updated yesterday. So yes, this is quite a year. It's scary. So it started off with a bang, all right? And it started off in the West and in Alberta in particular, but northeastern BC had fires. Saskatchewan had significant fires, as did Northwest Territories in May, a really active May fire season, and that's very unusual, okay? So record-breaking temperatures. This is from ERA 5, and this map was produced by Brian Brett Schneider, and he's on Twitter, and he's great to follow. So if you use Twitter, he has lots of interesting stuff, and I would follow him if you're on Twitter if you're interested in anything weather, climate. So temperature and fire are related. I'll talk in more depth about this, but generally, the hotter it is, the more likely we'll see fire. And so where did we see the fire? Well, we saw it in the West. So we also saw heat in June, and this just came out. This is from Berkeley, and the link's there as well. And you can see now the West stayed warm in Canada, but the East is warming up. And we had fires in Nova Scotia, and of course, significant fires in Quebec. Just crazy fires in Quebec. And yeah, so where the heat is, that's where we go. June 2023 is the warmest June on record. This is from Berkeley. There are multiple data sets of global temperature. So, but this is one that just came out. And so that's why I popped it on the slide here. Atmospheric blocking. So there was a significant upper ridge, and the 500, I still use millibars, I'm sorry, 500 millibar ridge, which is, 5,500, 5,600 meters, where we're seeing, we're seeing we may be seeing 600 or 6 kilometer heights soon this weekend in the southwestern United States. So these were very significant events, positive anomalies. And, you can see it was anchored over the BC Alberta border at this particular time. This is just taken from one of the models. But upper ridges are very important to fire, and I will talk more about why that is. The bottom one is for June, or actually towards the end of May. That's when attention started to shift to the east. But while the east was on fire, Nova Scotia and Quebec, the West was still burning. It's just it didn't get the attention that because of the events unfolding in the east. Now, the West is on fire again, but Quebec is still burning. It's just the shift is attention. At least the fires around James Bay are still very active. If we have time, I'll pop on the GOES site that I love. It shows you real-time fire. So extreme fire weather, and this is I borrowed this from Dr. Jan Boulanger with the Canadian Forest Service in Quebec City. And, maybe hard to see. The source is up there. It's from UQAM, University of Quebec, Montreal, in 2023 for various components of the fire weather index. And generally, the higher the number, the drier the fuels, the more fuels available, the faster the rate of spread, the higher intensity fires. And 2023 just sticks out like a sore thumb. This is just, it's extreme, and extreme fire weather drives the fire world. And here we go. So let's talk about pyro-CBs. Okay, so David Pearson is one of the researchers. He's with the U.S. military that's been monitoring pyro-CBs. Mike Fromm was doing it for years, and maybe Mike is still doing it. So he tweeted July 10th, 85 pyro-CB events in Canada in 2023 season. The previous record was 50 in 2021 for the entire season. The global highest in the last 10 years was 102 or whatever, 103. Where is that? So we've already broken that record. This he hasn't updated it yet, but there was a number of pyro-CBs last night in BC. So we're going to break that record. So these are very intense firestorms, and you can see pictures on the bottom right of a near visible geocolor on GOES 18, and you can see The mid-infrared, the whites are hot spots, and you can see that black is cold, the white's hot, and you can see the plume developing from the pyro-CBs. And these, they spread rapidly. They generate their own wind field, they can generate lightning, and they can start new fires. And yeah, we're just seeing a lot more of them, which means these are very high intensity fire. We're also seeing more fires burning through the night. I just looked the last few days, many of the fires in BC burning actively through the night. And we're seeing that because our nights are getting warmer, so the fuels are staying drier, and because the daytime conditions are more extreme, that there's this inertia or lag of intensity that can keep on burning through the night. So, I bring this up because the media, there's lots of stuff out there. Some of it's good and some of it's rubbish. Okay. And this is something, I'm not going to cite the source of this because I don't want to give them a platform. Okay. But this is what was said recently. Forests used to catch fire like this all the time. While unprecedented recorded history, our current fire season 2020, wildfire season of this size is pretty normal for pre-industrial, and that's just rubbish. All right. And they cite a paper inappropriately, okay, at times. And this is paper by Chavares. And the paper, it's a good paper. Yes, there was more fire in the pre-industrial period, but a 10 million hectare fire was not normal at any time. And I'd be surprised if any time in the history passed much over 10 million, because that's 3% of our forested area. Our forests cannot support fire cycles of every 30 years. It just, the forest would not be there, okay? So this is an extreme year. And to say things in the past happened, so it's not so bad. But the intensities changed. They didn't have 100 pyro-CBs. Pyro-CBs did exist in the past. Brian Stocks and I wrote a paper about Red Lake 7 in 1986. But they were unusual. They did occur, but now they're frequent. And these are very high. So our intensity is changing, and we are seeing more fire, and we will continue to see more fire. So let's talk about climate change. All right. So this is a observatory in Mauna Loa, Big Island, Hawaii, and it's the longest continuous record we have. And we're pre-industrial, this is about 270 to 280 parts per million, and currently we're around 423. The last time Earth saw 423 was about 3.5 to 4 million years ago, and as you can see, we're going up and up. And so carbon dioxide is a greenhouse gas. What does that mean? The sun emits radiation at shorter wavelengths because it's a higher temperature body. The Earth is a lower temperature body, just around 300 Kelvin. It emits most of its energy as long waves. Greenhouse gases like water vapor, carbon dioxide are more or less transparent to the short wave radiation, solar radiation, and somewhat opaque to the longer waves. So it traps the heat in. It's like throwing a blanket on your bed on a cold winter's night. It traps that heat in. And so this is one of the most, water vapor is the primary one. And there's a natural greenhouse effect going on, and we'd be a much colder planet without it. So, but we're enhancing it with human activities, primarily fossil fuel burning. And of particular concern, now, the last one was parts per million. This is parts per billion, okay? This is methane, and it's increasing much more rapidly. It has a longer lifetime than carbon dioxide and is much more effective at trapping that heat, anywhere to 20 to 80 times more effective than carbon dioxide. So this is particularly concerning as it continues to increase even more rapidly than carbon dioxide. So the temperature is going up and up and up, and odds are that 2023 will be the warmest year on record. The year's not over yet, so we can't say with certainty, but the odds are it will be. And also, we're going into an El Nino, which is generally a warmer Earth pattern. I like showing this graph. I gave my first talk on climate change in 1985. Okay, and this is, this is monthly global temperature anomaly using a 1951 to 80 baseline. And you can see the last time the Earth had a month that was below normal was December 1984. So what is that? Over 400 months of above normal or above the anomaly, the baseline. It's it's a warmer world. So here's the 2022 in the upper left year, and you can see it's not equally distributed, and there's year-to-year changes as well. And 2022 had La Nina, and you can see that in the Pacific Ocean, the temperatures were actually below the 30-year average. And here's May 2023, you can see that the excessive heat in North America there, northern North America. And once again, the links are at the bottom there. So as I said, heat's not distributed equally. This is 2022, but this is common for many years. Northern high latitudes are warming faster than the rest of the globe. And I'll show you a bit more about that. Land ocean, the land's been warming much more rapidly than the ocean, though things may be changing as the oceans are starting to warm more rapidly, at least this year. North Atlantic, of course, temperatures off the Keys are just, Florida Keys are just insane, 95, 90, 97, I heard 98 or 99 the other day, I'm not sure, but wow, fires occur on land. So, we are warming, okay? And here's temperatures for June, July, and this is primary fire season in the Northern Hemisphere. And so this is a concern, definitely. Here's animation, and this is degrees F Fahrenheit, unfortunately. Reds are warmer than normal, blues are colder than normal. And you can see the years shown in the bottom center there in the Southern Ocean. You can see kind of up and down until about the 70s, and then it starts becoming a much warmer world, especially at high northern latitudes. These are, observations. These aren't, model results. So there was a Canada's Changing Climate Report came out, I don't know, 6 years ago, somewhere in there. The West and the North are warming faster than the East thus far, and the Arctic areas are warming at 3 to 4 times the global average. Canada's warming at twice the rate of the rest of the world in that ballpark. So we are high northern latitude country, so we are warming significantly. GCMs, global climate models, general circulation models, pick your acronym. It's going to be a warmer world. Grace increases high latitudes, winter, spring. Arctic ocean ice may become seasonal at some point this century, and that's going to have a tremendous impact. Of concern for fire folk is projected increase in extreme weather, heat waves, drought, but floods, windstorms, ice storms. What's concerning to me is COP26 and COP27 conventional parties. There seems to be this move away from mitigation to adaptation. That's really scary, like they're almost throwing in the towel. Now, if all the countries meet their obligations, we'd be just under that blue line, okay? Which is still, near 3 degrees of warming. I think they say like 2.8 if everyone does what they say they're going to do. Unfortunately, our track record in Canada and other places is we've done a poor job meeting our objectives. I'm still extremely concerned for this planet, where we're going. We need, there are areas where we're doing things, but we need to do a lot more. So here's an animation, and this is from the Canadian model. So it's in degrees Celsius, great, but you'll notice the scale of 10 to 15 degrees. The year is shown in the top right. This is a more pessimistic scenario. This is the CMIP RCP represents carbon pathway 8.5. I'll run it one more time, but it's good. If these these models have been doing a really good job on getting temperature. Impacts we probably underestimate, but temperatures, this is a more pessimistic one, but we're going to warm. The scary thing is, even if I had a magic wand and said no more fossil fuel emissions right now, we'll continue to warm for 30 years at least because of lags in our climate system. So we're going to warm. So there's numerous papers out there on fire and climate change and what the impacts are. And this is one that I was involved in, almost 20 years ago, and suggesting a doubling of area burned. And since then, there's been numerous papers suggesting a quadrupling, a quintupling, 11 times increase. As I said, in Canada, we've kind of doubled since the 70s, actually a little bit more than doubled. Western United States area burns increased by a factor of 4 since the 1970s. So let's talk about fire and temperature. I've been telling you about, hey, it's hot, and we're seeing more fire here, seeing more fire there. Why is temperature so important to fire? And here I'm not talking about individual fire, I'm not talking about the Lytton fire or the Fort Hood fire specifically, where things like wind become really critical. Here I'm talking about fire over large areas, say like the province of Quebec, for a longer period of time, say like decades. Why is temperature so important? Longer fire seasons, and we're seeing that already. Our fire seasons in Canada are longer than they used to be and will continue to lengthen, which means there's more opportunities for a fire to start and burn. Second, the warmer we get, the more lightning we expect. So more lightning, all things being equal, means more fire. And recall I said, even though that lightning is responsible for about half the starts, it's responsible for almost all the area burn. And if you look at the trends, human-caused fires, the number and area burn have been going down, which is good. Things because of education, fire bans. So that's why I hope our number of human-caused fires are going down. However, lightning causes more than made up for it in terms of area burned. And the last is probably the most important, but probably the hardest to follow. So as the atmosphere warms, the ability of the atmosphere to suck moisture out of the fuel, out of that vegetation. Here I'm talking about dead fuels, grass, needles, leaves on the forest floor, increases almost exponentially as temperature increases. So unless we see an increase in rain to compensate for this drying effect and the warming, we're going to have drier fuels. And the models of the future suggest we're not going to see enough rain to compensate for it. So the bottom line here is a warmer world means drier fuels. Drier fuels means it's easier for a fire to start, easier for a fire to spread, and it means more fuels available to burn, which leads to these higher intensity fires that are difficult to impossible to extinguish. So a warmer world for places like Canada mean more fire. So let's talk about the jet stream. Well, yeah, okay. It's the band of fast-moving air. If you've been on a plane, if you fight the jet stream, you get to your destination late. If you're with the jet stream, you get across the Atlantic really quickly. So, it really dictates where our high pressures go, where low pressures go. If it's a fairly strong, like a fast-flowing river, the highs and lows go through every 3 to 5 days. You generally don't have a fire problem because when the lows go through, it brings you rain. If you get rain every 3 to 5 days, you don't have a problem, right? It gets its energy from the temperature difference between the equator and the Arctic regions in the northern hemisphere. Recall I just said that the Arctic is warming at 3 to 4 times the rate as the rest of the globe. So that temperature difference is getting smaller. So instead of a fast-flowing river, now you got a lazy river with eddies and whirlpools, stagnation. And that stagnation, that blocking pattern, sometimes called omega block because it looks like the Greek letter omega, it's really important to fire. And so what's going on is these high pressure system, air is sinking, warming, and drying. So let's say you have a forest, and let's say you had lots of rain, but this high pressure system parks in your region for 7 to 10 days or longer. And no matter how wet your fuels were, in 7 to 10 days, they're going to be dry and ready to burn. So all you need is ignition, whether it's people or lightning. And when that ridge shifts or breaks down, a cold front is often associated, often with lightning. strong shifting winds, lightning, these are all key factors for fire spread. So ridges, blocking ridges, and fire researchers have known for 50, 60 years about this relationship. With climate change, there are people who are, I think we still need to do more study, whether it's thermodynamically driven because of warmer temperatures, we're seeing stronger, longer lasting ridges, or dynamically because of that temperature difference I talked about. It's still a area of study, and you'll find people on both sides of the fence. But the logic is sound. I think over time, for sure, whether it's happened already, I'm not sure, but we do seem to be seeing more extreme weather, droughts, fires, flooding. We are seeing it, and it's happening. So yeah, stay tuned. So I'm wrapping up. I know I want to leave some time for questions. More fire activity in the future. Our fire management approaches have to adapt to this new reality. Some people like the term normal or new normal. I don't like that because it sounds like it's a steady state. Rather, we're on a trajectory and we're going downhill, Dante's circle of hell, whether we're in the third or fourth cycle, I'm not sure. New territory, uncharted territory, no historical analogs, high intensity fires. We're seeing them in places where we don't normally see them, and at times of the year when we don't normally see them. So, relying on our experience or analogs may not be the best approach anymore. Unfortunately, fire and society will interact and intersect, and it's unfortunate, but more fire in the landscape, it's going to bump into infrastructure and community at time. We have to learn to live with fire and smoke. It's not going to go away. It's the cycle, Mother Nature at work, and we can't beat Mother Nature. We should try and work with Mother Nature as much as possible. Fire is a multifaceted issue, and we need a multi-pronged approach. And you can see pictures of, this is a repeated fire area in Northwest Territories, and it's almost like a desert. That's Chuckhead Creek fire. And I'm going to stop here and just, I'm on Twitter, Canada Wildfires on Twitter, the Canada Wildfire website. We're on YouTube, Instagram. Yeah, we're all over the place. So come check us out if you want. I'm actually looking for a graduate student to work on fire spread days. So if you're interested in doing a master's program at Thompson Rivers, look me up, and I'll stop there, Amir, and try and answer questions.
Okay, thank you very much, Mike. So we have a few questions on the chat, and I'll read it, and maybe you can respond to those. So the first question is, what is the recent paper on smoke mortality you referred to?
So if you look at David Bowman, I just got a Google alert on it, and it's by David Bowman. He's at University of Tasmania. He's one of the co-authors, and I'm trying to look it up on my phone as we speak, but yeah, sorry, it's on my other email account. But search David Bowman, and it just came out.
Okay. The other thing is that if you do have some very specific questions which are not answered here, or you didn't have a chance to ask them, then you can certainly write to Mike at his email, which is mflannigan, FLANNIGAN @tru.ca. That's Thompson Rivers University.ca. So the next question is there an agreement between transboundary smoke haze between Canada and the US?
I don't believe so, but I'm not positive about that. If there's yeah, that's outside my knowledge. Okay, I don't know for sure. I don't know.
Okay. Then the other question is, so what are the short-term solutions? As you said, even if we stop using fossil fuel tomorrow, we won't see the impact for decades. How can communities and government deal with the increased wildfire smoke threat now and its impact on the health and safety of Canadians.
So that's a seminar. I can, yeah. So maybe I'll talk about smoke first. All right, and the first thing you can do is monitor the situation. Environment Canada has air quality health index. If you're in Canada, Purple Air, if you check their website, has lots of data. So when air quality is bad, don't do anything strenuous outside. If you have to be outside, if it's really bad, wear an N95 mask, it'll help. That's why those masks were developed, was for wildland fire smoke and not COVID. Okay. Stay indoors, and even if you shut your window, if it's a prolonged exposure, the air quality inside can be as bad as outside. So get air filters. They work, and yeah, it's smoke is a real. The more we know about smoke, the more we know it's really bad for human health. On the other side of things, we can try and make our communities more fire resilient. There's programs called Fire Smart in Canada, Fire Wise in the United States. They have 7 principles for homeowners and communities to better protect themselves. I think we can do a better job with fire bans and even forest closures, using them in advance of the situation. We often use them as a knee-jerk reaction rather than preparing for that extreme hot, dry, windy weather. Forest closures are very unpopular because you shut the forest down for industrial activity, recreational activity, but stops human-caused fires. All human-caused fires are preventable. So that's one area where we can increase the lightning. Yeah. And, the climate change side of things. Yeah. Until we do something with climate change, we can't change how many hot, dry, windy days we have. We can't change how much lightning we have until, as a global society, we deal with human-caused climate change. There's things about building codes we can do for fire, community planning. So there's lots of things we can do, and we are doing. But the bottom line is we're going to see fire, and we're going to probably see more fire. But area burn is kind of misleading, because some of the areas that are burning right now, it's natural, it's not bad, except for it produces smoke that times, based on the wind pattern, can blow it to cities. If you're downtown Toronto, the likelihood of your place burning down to wildland fire is 0. However, fires in Northern Ontario or Quebec can make your life miserable for days and even weeks. So that's the impacts of fire. That's not a complete answer, but it's a start, Rachel. And I give talks all the time, and send me an email. I can send you when I talk more specifically about what can we do.
Okay, the next question is, you have talked quite a bit about the influence of climate on wildfire. What about the other way around? It seems the growing burn area, we now are seeing more carbon emissions from fire than carbon sequestration in post-fire regeneration. What are your thoughts?
We didn't have much time to go into carbon in this talk. And if you're interested in current distribution of carbon and smoke from fires, Mark Parrington is on Twitter. He's a great person to follow if you want. I've almost had time to put a slide in with some of his graphs. But you raise a good point. And, so I've been arguing that the warmer we get, the more fire we see. Well, there's an argument, the more fire we see, the warmer we'll get. And here I'm talking specifically about peatlands, okay? Because upland forests, they're over the longer period, they're pretty close to carbon neutral, okay? From year to year, there's ups and downs, and our Canadian forests, Canada argued forcefully in Kyoto Article 3.4 to include forest management. And then after the government did a look into it, it decided that more likely than not, our forest would be a carbon source rather than a sink. So we opted out of the article we fought so strongly for. And it's true, most years in Canada, our forests are a carbon source due to fire and bug kill, insects and things like that. But here, when I talk about peatlands, so upland forest, carbon neutral, pretty close over the longer term. Peatlands are a carbon sink. They've been storing carbon slowly for thousands of years. And a fire can go through and release all that carbon into the atmosphere. And studies by Susan Page in Indonesia during a particularly bad year, an El Nino year, 97, she found that emissions from peat fires in Indonesia were equivalent to 20 to 40% of global fossil fuel emissions. Peatlands in the boreal forest of Canada, Alaska, and Russia are 30 times greater than Indonesia. So it's a potentially significant increase in carbon into the atmosphere that feeds the warming. So more fire, warming, more fire, more greenhouse gases, more warming. There's checks and balances in the system due to albedo, which I probably won't have time to get into, but it's a concern. Also, a recently burned area in our permafrost areas, it has a blackened surface, which causes warming and accelerates the thawing of the permafrost. And there are hydrates, particularly in the methane, that can be released, and how much. Yeah, so there's lots of feedbacks. Whether fire is a warming agent or a cooling agent, that science is still being researched, and there's a great Nature science paper to come out to resolve it, because there's, as I said, checks and balances. Albedo, northern albedo, you take a green conifer forest which absorbs solar radiation in winter, it's now white because of the snow, because the trees are no longer, they're dead. A greater albedo, which is a cooling agent. So and also smoke blocks solar radiation. So there's checks and balances, but overall, I think fire is a warming agent due to increased combustion.
Okay, an earlier paper you referred to by Dave Bowman, someone has pointed out a paper in Nature by Johnston and company. So maybe people can look into Nature about that particular question.
Yeah, I'm not sure if that's the newest one, but Faye Johnston she did the work that I referred to about 339,000 premature deaths. So if that's the paper, but there's more recent work coming out now.
Okay. Can you please unpack again the argument that fire was worse in the past?
Well, this is from observations you can do fire history studies using fire scars, and you can use paleo work that use charcoal in lake cores. And there's micro charcoal and macro charcoal. Micro can travel long distances, macro has got to be in that watershed, depending on what the lake looks like. So from these studies, at times in the past, it was warmer than the current day. And also during settlement periods, there was lots of fires started by people to clear the land. So there's a number of reasons why at times there were more fire. Also, fires in the past were not fought until recently. So fires were allowed to burn and burn and burn. Fire management in some regions has reduced area burned amounts, and some places I would argue significantly. Also, land use change. Okay, so we went from a natural state. Now we have agriculture that creates vast areas that are less likely to burn, urban areas less likely to burn. So these are all reasons why there's less fires. Prior to Europeans arriving, were not fought, and they were just allowed to burn. Indigenous peoples have been using fire for thousands of years, and seem to be we're doing a much better job of managing fire than what we currently do. And so we have lots of lessons to learn from Indigenous peoples in the management of fire. But indications are there was more fire in the past in Canada and United States than we currently see, though I would argue that this year may be an exception. This year would not be a common year in the past at all. Unless you include things like grass fires and things like that. But in terms of forest fires, no, this is an extreme year, and we won't see another year like it for a while, I hope.
Okay. And then there's two related questions here. What are the meteorological gaps when it comes to fire weather forecasting? More observations, better techniques, data visualization? And the second question is, where can meteorologists contribute, provide value?
So yeah, so fire management is done by the landowners. So in Canada, that's the 10 provinces, and 2 of the 3 territories do fire management. Parks Canada does fire management. Some of them have their own fire weather forecasters. BC has a great crew of meteorologists who actually do provide weather support. So fire weather forecasting, I worked as a fire weather forecaster for Atmospheric Environment Service. This is a really interesting question. So I would say pyroconvection is now, there are some preliminary models. When will we see pyro-CBs develop is a gap that we are addressing. How best to use ensemble fire weather forecasts, how to use weather in fire growth modeling, especially in terms of ensemble fire weather forecasting. So, I mean, traditionally we have fire growth models and we just have one forecast of the fire weather and run the fire growth model. Now we use ensembles where there's 50 fire perimeters. How best do we do that? I mean, which perimeter? And we know that ensembles, even if you show the whole range of ensembles, sometimes weather does its own thing and it's outside the whole range of ensembles. And how do you deal with this uncertainty? How do you use this? Visualization, absolutely. You know, we're getting more and more into dashboards. You know, COVID brought us lots of dashboards that, you know, we can learn from some of that experience. But yeah, visualization is really important. There's also what we call, for decision makers, there's various level decision makers in fire management. But one of the important ones is, do I fight that fire or not? And that has to be made really within a couple of minutes, okay? So some fires, if it's 2 kilometers from Kamloops, that's unwanted fire. You send resources and you try and put it out right away, because that's critical. Because sometimes you only have like 15 to 20 minutes before that fire is basically out of control and you've missed your window. The Lytton fire, within 20 minutes from the time it started, the town was on fire. It was kind of like already there. So making decisions and having that the best fire weather forecast for the next couple of weeks and having the best fire growth modeling done in those couple of minutes so that you can make a decision as to whether that's a priority fire or one of these fires that we can monitor because it's farther north and maybe doing something beneficial, like taking out mountain pine beetle or spruce bloodworm in the east. So, but yeah, I have to give that some more thought. That's a great question. Thanks.
Okay. The next question is, can you please elaborate on the ability of smoke being suspended in stratosphere? Will it intensify with lazier jet stream omega patterns?
Okay, so these pyro-CBs, pyrocumulonimbus, they have a significant column. This is a pyro-CB picture taken by Dennis Quintilio, 2014, a very active year in Northwest Territories. The thunderstorm, which is injecting smoke and moisture into the stratosphere, stratosphere is very stable, and then it stays in the stratosphere until it settles out, which can take a long period of time. And the Australian fires, they had very bad fire season 2019, 2020, because the Southern Hemisphere, you know, our winter is their summer. They calculated that the amount of smoke injected from their pyrocumulonimbus was equivalent to a moderate volcano, okay, in terms of the amount of smoke injected. So it's the pyro-CBs. So how's the jet stream play into that? Well, the jet stream's stagnant, you get more, the drying out of more fuel, which leads to higher intensity fires. The higher the intensity of the fire, the more likely a pyroconvection. It doesn't guarantee it. There's also the stability of the atmosphere. There's also mid-layer moisture plays a role. So all these facts, but basically more extreme fire weather, more pyroconvection, more smoke into the stratosphere. And you think this would be a cooling impact, and that's what I thought originally, because smoke blocks solar radiation, should be cooler. It's the moisture that's injected into the stratosphere that apparently, I have to read some more on this, but according to some recent papers, the moisture causes a warming in the stratosphere. So, yeah.
Okay, so that's all the question that was in the chat. It is now past 1 here in Toronto. So I'd like to, first of all, thank you, Dr. Flannigan, for a very interesting and a very timely topic, I would say, because we've been affected by smoke all across Canada so far this summer. And I think your insight has really brought some background information that is useful to, I would think, all of us. And secondly, I would like to thank all the participants. This is the most popular webinar that we have featured here in the Toronto Centre. I think at one time we had about 91 people join us. So that was very good. So I'd like to thank everyone and look forward to meeting some of you in the next few webinars down the road. Thank you again, and goodbye.